All right, apologies for the delay. Now starting Battlecode Lecture 7. All right, and are you gonna kick it off with the balance changes?
Mhm.
All right,
Okay, so first part of lecture 7 is going to be the balance changes that we made after sprint 1. Let's get started. So here we go. The first balance change was we made a new method called broadcast message. And what this does is it allows towers to send a message to nearby towers within a radius of square root of 80. This counts as a message sent even if multiple towers receive it. So only one message sent, not one for each tower. We also buffed the defense towers. So now whenever a robot or whenever the defense tower attacks a robot, then the defense tower makes money. And I think this money level upgrades with like the level of the tower, I'm pretty sure.
yes, it is,
Yeah.
I believe like 20, 30, 40, depending on the level of the tower.
Yep. And then we also buffed moppers. Now instead of just being like able to attack one row of 3 with the area of effect attack, now it can hit 2. So basically this would be like a rectangle, 2x3 rectangle in front of it of 6 squares. And if there are robots in the squares, then it steals paint. Or removes paint, I mean. So next, we changed the resource pattern because it's really easily tileable. Now it's slightly less easily tileable. I think the Zoom video might be blocking it, but in the top right, there's the resource pattern. Let me see if I can
drag it out of the way.
Yeah. Okay, cool. So as you can see at the top right of the slide, this is our new resource pattern. It costs 200 money now. Previously, it only cost bytecode. And of course, the paint required to paint it. The resource patterns start generating resources after existing for 50 rounds, not immediately now. This is to incentivize people to build them earlier, even though they've been slightly nerfed. Then we also have paint penalties. So as you might have seen in sprint 1, there are a bunch of strategies where like there were just like robots on every square for like both teams, and this kind of made things get stuck. So now there's a penalty for allied robots being right next to each other on all territory and not just enemy territory. This includes neutral territory and allied territory. I think it is less for, it is less for neutral and allied compared to enemy territory. It's still at 2 paint per turn, right?
Yep, 1 paint per turn for neutral or ally and 2 for enemy.
Yeah. And when robots get to 0 paint, they lose 20 health per turn rather than the original 10 turn death counter. This is just more logical, and you can more easily see it in the client because there's a health meter on the robots. Here are a few more changes. So we also increased the bytecode limit for robots to 17,500. And we did not change it for towers. And then also we just added an extra method to check if, or add an extra field map info to check if a certain location is a resource pattern center. I'm pretty sure this is only checking if it's been completed. The resource pattern has been completed. So if you just draw the resource pattern and you call this function, it's going to return false. Can complete resource pattern returns false if there's already a resource pattern center of a location, so that you don't build one on top of the previous one, because now it costs more resources than bytecode. Okay, next we're going to talk about sprint 1 strategies.
All right, so yeah, we're just gonna go over like some of the things that we saw yesterday, what strategies worked well, what strategies didn't work as well, and like maybe some things that you could take away from that for your own bots. All right, so the first like area that I'd like to talk about is sort of like the trends that we saw with how people manage economy based on sprint one. The main thing that like was notable to me at least was just overwhelming use of resource patterns. Like at one point, I think I saw the top team had like 111 resource patterns or something absolutely insane like that, which was not good. That made me sad. So with our balance changes, resource patterns will be like quite a bit less useful now. But I think it's still like the main takeaway is it's very important to like build as many of them as possible and like right off the bat, like make as many resource patterns. With the new balance changes, there's like a little bit more of a trade-off with resource patterns now, because you do have to wait 50 turns before they're actually active. And they also cost money. So like you kind of do have to weigh like whether or not it's worth it or not to build the resource patterns. But still, like I said, watching games yesterday, I didn't really see a game where like the team with less resource patterns ended up winning. Like whoever had more patterns, it kind of just snowballed to them winning the game. So I think that's something that's very important to focus on. Although with new balance changes, it is a bit more important to build them in like a safe place where it's less likely for the enemy to be able to destroy them because they have to exist for 50 turns consecutively without being destroyed for them to actually become useful. And in terms of towers, main thing we saw is like roughly equal paint and money towers. There was like maybe people building a few more money towers than paint since like money was generally the limiting resource, but still like roughly equal split. And so like maybe that's something that you can emulate in your bot. We're hoping to also see more defense towers in the future with our balance changes. But that's like sort of what we saw yesterday. Another takeaway was I saw that like the majority of teams didn't really want to move their robots off of allied territory, like because of the enemy paint penalties and things like that. But actually, like our top team, we saw quite a bit like of a more aggressive strategy, moving on to enemy territory and just attacking enemy towers without worrying about the paint penalty. And this actually ended up working really well. So like maybe it can be more helpful to start adopting some slightly more aggressive strategies. And we also saw splashers being like very, very useful in terms of trying to expand your territory as quickly as possible. One more comment. We had some very interesting games yesterday in which the entire board just got absolutely filled with robots. Back when we were running the tournament, there was this one match that took like 20 minutes to run on our server, and we were like, what's going on? This is very strange. And then I got this text from one of my fellow devs that this is why it took 20 minutes, which, yeah, that should have been pretty obvious. But with our new balance changes, we have like penalty for adjacent allied robots, even on your own territory. So this is now a very bad idea. Don't cluster your robots like this. We realize that this will probably make micro like a good amount more complicated. You'll probably have to put a good amount of thought into how to pathfind your robots so that they don't go next to each other, which honestly might be a little bit difficult. I would have liked to go over that in the lecture today, but since we just changed it this morning, we haven't really implemented that. But that is like a major thing to think about, is how to prevent your robots from getting clustered like this. Yeah, those are like all the big trends that I wanted to talk about. So next, we're going to jump into just implementing a few more features for lecture players to give you some other ideas of what you can do. All right. All right, you want this?
Oh, yeah.
Sorry.
Okay. Thanks. Testing the microphone. Is it on? Oh, I think it's off.
Is it?
Yeah.
Oops. There we go.
Testing the microphone. Cool. Okay, so next thing we're going to talk about is attack micro. So when you have a robot attacking a tower, one thing we saw a lot in sprint 1 was the robot would it would stand outside of the tower's attack radius, then move in, then attack, all in one turn. And then after they attack, well, I mean, on the next turn, they would attack first and then move out, which is really interesting. And that allows the robots to attack twice as often as the towers, which is a really useful strategy. I'm going to implement that right now in lecture player. To do this, of course, the robots have to know where the enemy towers are. And there are a lot of ways to do that. You can send robots to explore. You can use symmetry. For using symmetry, you just note that like there's a requirement in our maps that all of them have some kind of symmetry, either reflectional, like horizontally or vertically, or rotational symmetry by 180 degrees. And you don't know what the symmetry is automatically, but if you send robots to the right places, you can explore and figure it out. And some ways to do this would be to look for walls, because walls can't be created or destroyed, or look for ruins and just match them up. Like have a list of potential symmetries and like eliminate them if you notice that there's an inconsistency on the map. And then you can eventually narrow down to the correct symmetry, and that will help your algorithms. So let's get to implementing this now. As you can see, this is the robot player file for lecture player. Might need to zoom in a bit.
Use Command plus.
Okay.
You could also click the like file icon in the sidebar just to make it go away so there's more room.
Oh yeah, that's a good idea. Okay. First thing we're going to implement is let me see if I can find it. So it's right here. So you might recall from the previous lectures that use lecture player, run soldier is a function which runs every turn for every soldier robot. What? Sorry. Okay, I'm back. And we've added a little bit to this. So we have a state machine now. There's the robot state. What is robot state? Isn't it enum? Yeah. So right here, you can see this is robot state. There are 4 possible states. There's starting, which is what all the soldiers start in. There's painting pattern, which means the soldier's trying to paint a tower pattern. There's exploring, which means it's trying to look for ruins, I'm pretty sure. And attacking, which is the one I'm going to focus on right now. That means the soldier's trying to find an enemy tower and pathfind towards it and then attack it using this new micro. So let's go down to the run soldier method and start implementing. So first, there's some stuff already implemented here. If the state's the starting state, we want to make it not the starting state, so it actually does something. And we just like, this is basically random. Like if the robot has an odd ID versus even ID. So if it's odd, then you put in an attacking state, and if it's even, you put in an exploring state. It makes it so that there's an about 50-50 balance between the number of robots in each state. Then after that, then we just we do an if statement to condition on which state the robot is currently in. So let's head down to the attacking state. This is what we're going to implement first. So if a robot's in the attacking state, first we need to check if it's currently targeting a ruin. We have this field, target enemy ruin, which is added to the top of the file. It's a static field. Even though it's static, it'll be different for every robot because that's how the Battlecode system works. So let's just check if this field has already been set. If it hasn't, then we want to set it to a potential enemy power. Oops, this is supposed to be null. This is not an integer. Yep. So if we haven't set the target enemy ruin field, then we want to figure out a location of an enemy tower. And as I said before, there are multiple ways you can do this. And the way we're going to do it now is taking advantage of symmetry. And I don't want to implement figuring out what the symmetry is right now. So I'm just going to assume the symmetry is vertical, as in like reflection across a horizontal line. So first, we're going to find the locations of allied ruins. So to do this, we're going to get nearby map infos. What is there? So we're going to sense the nearby map infos. And of course, this is going to be an array list. Pretty sure. Let's just check. Oh, this is an array. Okay. So we have an array of nearby map infos. This is all locations within the vision radius. So the maximum we can see right now. Then we're going to loop through these. And check if any of them have ruins. Or actually, maybe there's a method to sense ruins. Hold on. There is. Let's just use that. So sense nearby ruins of radius squared. If we put -1, that's the maximum. So let's do that. And this returns map location. Okay. So now that we have the nearby ruins, we're just going to see if there is a ruin. So if infos.length is greater than 0, then we want to get a ruin to track. So map location ruin equals infos of 0. And then this is an allied ruin. We should probably, is there a way to check if this is yeah, well, for the majority of cases here, this is going to be an allied ruin because the robots start on the allied side and then move to the other side. But if you wanted to introduce a check, then you could probably loop through these map locations and just like check each one to see if it's allied ruin. Sorry, to see if it's like on your side or on the enemy side, or you can check if it's like near enemy towers. You just want to make sure that like you're not trying to attack your own towers. So assuming that this is an allied or ruin on the allied side or near your towers, then if you look at the symmetric one on the other side, it's probably going to be near the enemy. And let's just get that location. So application enemy equals new map location. And the x value, well, if we reflect across a horizontal line, the x value is going to be the same. So ruin.x. And here we want the reflection. So this is going to be going to get the map height, subtract 1 and subtract ruin.y. And the reason we subtract 1 here is because it's 0 indexed. And the first location is 0 and the last location is map height -1. So now we have the enemy ruin location. And for the purposes of this bot, we're just going to assume it has a tower on it. But for larger maps, where a lot of the ruins are probably going to be empty for a while, this might not be a good assumption. And you might want to actually send robots to scout out this place. So assuming this has a tower, we want to attack the tower. So target enemy ruin equals enemy. And now this should remember that it's trying to target that specific ruin. And hopefully it has an enemy tower. Okay. So now that we've implemented that, what happens once we found this? So once it's targeting an enemy ruin, or if it remembers one from a previous turn, then we want to do one of a few things. First, if it's within the attack radius, note that the robot and the tower have the same attack radius of 8 units squared. If it's within the attack radius of the tower, then what you want to do is, hold on, let me just delete this to-do message. Okay, so what you want to do if it's close is attack and then move away. And as you can see here, we're attacking. If you can attack, then attack. And now we're going to move away from the enemy ruin or tower, hopefully. So the way to do this would be direction away equals RC dot get location dot direction to target enemy ruin, and then opposite direction. And once we know the direction, let's see if we can move in that direction. So if RC dot can move of the direction, then move in the direction. If it can't, well, the ideal thing to do would be to figure out how to navigate away from the tower's attack radius so the tower can't reach you anymore. But for now, we're just going to do something simple, which works in a lot of cases, which is if you can't do that, then just check the adjacent directions, by which I mean rotating by 45 degrees left and right. So if RC dot can move of away dot rotate left, then move in that direction. And then if you can do the same thing for rotating right, then that's what you want to do. This ensures that the robot doesn't get stuck in a place where the tower can keep attacking it every turn, and it can also only attack the tower every turn, which is not the ideal micro as we saw. Okay, now that we've implemented this, there's, I think, one more thing we want to do for the tower attacking thing should work. First, note that I've called the bug2 function here. This is implemented in the pathfinding lecture. I don't know why it keeps doing that. What? Okay, cool. I think I fixed it. So bug2 is just a navigation function, and the arguments are just robot controller and the target. That's pretty simple. This is an else block, so this is it's not near the tower. Also, just one thing to note is we don't want to only do the bug. We want to check if it can get within 8, and then if it can, you want to move in and attack immediately. You don't want to keep getting closer where the tower can attack you first. So let's just check that. So let's loop through all the directions. And for each direction, let's just get a new location and check if it's within the range, which is 8 units squared. So if the robot decides to move in this direction, then it would be at this location. And then if new location dot distance or is within distance squared 2 of the target, and the distance squared, which is 8, is when if it's within there, then you want to move in and attack it. So if RC dot can move of D, RC dot move. Yep. And then after this, if RC dot can attack of the target enemy ruin, this will also check if it's a ruin or a tower, because if it's a ruin, it obviously can't attack that. Then attack of target. And then we don't want it to do this multiple times because it can only attack once per turn. So let's break out of the loop. And actually, we also don't want it to move multiple times, so we will put the break there instead. Okay, so I think that's pretty much it for robot attacking tower micro. And at the end of this lecture, we'll test this whole thing and see how it goes. Okay, now I'm gonna pass it on to Hank for where's the slides? There we go. For the next section of lecture 7, which is going to be on more strategy and some implementation stuff too.
I'm just gonna talk loud.
Okay.
I don't like that mic. All right, so we're gonna implement like a few more strategies that can help out your bot and help out lecture player. So the first thing that I was thinking of doing is if you're able to paint a pattern for a tower like very quickly and efficiently, right off the bat, that could sort of give you an advantage versus like if you take multiple bots to make the pattern or take more turns to make the pattern, that could slow down your early game economy and like make more of a difference than you would think in terms of how well your bot does. So the first thing I'm going to implement is like a pretty simple algorithm for just trying to paint a tower pattern as quickly as possible using just a single robot. And like assuming the robot starts out with a decent amount of paint, like at least like 75%, it should be able to go through and in like 25 turns, like be able to paint the pattern on its own. So that's one thing I'm going to implement. Another quick thing that I wanted to do is show off the new broadcasting function that we implemented in the updates just to show you guys how to use that and show you how it might be useful. And besides that, I'm going to show like a very simple algorithm for deciding which types of towers to build. It's going to be nothing too fancy, essentially just like alternating between types of towers, but just improving on lecture player, given that right now, I believe it only makes paint towers after the initial money tower, which is not very good. So let's jump right into it. Here's my code. Okay, might be able to see this. Yeah. All right.
Which part?
All right, it's fine. I can find it. Yeah. All right. So the first thing I'm going to do is the broadcasting thing that I mentioned. So if you recall from, I believe, lecture 4, that was about communication. Evan implemented this strategy where bots would broadcast a message to tell towers to like save up coins in order to build another tower. And that worked pretty well, although it was like pretty difficult with the old communication system because a lot of the times like not all the towers would get the message and then they just wouldn't save up at the same time and it wouldn't really work. So I'm going to add like a quick broadcast here so that when one tower receives a message to start saving up, it also just broadcasts that same message onto the other towers. And pretty quickly, like all the towers should get the message and start saving up at the same time. So in order to do that, I'm just going to say rc dot broadcast message. And then same as before, it's just going to be like the save chips message. So that's message type dot save chips dot ordinal. And that should work. That should just like every time one tower gets the message to start saving, it'll just send it on to another one. And that should cause the message to propagate between all the towers and they should all start saving. So that's like one thing that this method could be useful for. Okay, so besides that, the next thing I'm going to do is we have some helper functions that are somewhere in this file. Where did they go? Here they are. Okay. So one function that I'm going to implement is this helper, just like for deciding which type of tower we're going to build, and we'll use that later. So like one thing I saw from looking at the replays in Sprint yesterday was it seemed like after the initial towers, they would build like their first 2 towers after that is money towers. And then after that, it would be like roughly 50-50 split between paint and money, or like honestly different depending on the team. But this is just going to be a pretty simple example. So I'm going to make it so that if the current number of towers gets something called get number of towers. If this is less than 4, I'm just going to build a money tower all the time, like not alternating, just because I think the first few towers, it might be optimal to build money towers. So I'm going to say return unit type dot level 1 money tower. And otherwise, I'm going to like essentially alternate based on the number of towers between like paint and money. So I'm just going to say return, let's use a ternary here, return rc.get num towers mod 2 equals 1. If yes, then we'll return unit type dot, we'll just do a money tower. Otherwise, we'll do the paint tower. And yeah, that should work pretty simple. We'll be using that later. I'll also explain this function in a minute when we get to that. Okay, so as Max said before, we sort of have this like state machine that determines what the robot should be doing at any given time. And the section that we're going to be implementing now is the one for exploring slash like also the one for painting the pattern. So for the exploring section, all of this stuff that we have in the file right now is pretty much things that was copied from the lecture player that you guys have already seen. Just like looking for ruins, moving randomly, that type of thing. But the part that I'm going to change is basically this part that will decide when to transition from the exploring state to start like my new code for painting a tower pattern, which will essentially replace what was here before and ideally paint the tower pattern more efficiently. So, sorry, just one second.
Which one is it?
It's in Run Soldier. Yeah. Yep, right there. All right, so here this is the old code. After we search through the ruins, we're just gonna check if we found a valid ruin. So that's just if current ruin is not equal to null. And then if so, if we're pretty far away from the ruin, then we want to move closer before we start trying to build a pattern. So we're just gonna say if current distance is greater than 4, then we're just going to use one of our pathfinding algorithms. Honestly, it doesn't really matter which one. To move towards the target location. So we're just going to move towards that ruin. This does not work because we need to say get some application. Otherwise, this is the part where we're going to transition to the other state of our robot, which is going to be like the pattern painting state that does the new efficient pattern painting algorithm. So if we find that we're close enough to the ruin to start painting, we're going to transition to the other state. So we'll just say state equals robot state dot painting pattern. We also want to decide like which type of tower we're going to try to build. So we're going to use that helper function from earlier. We're going to say paint tower pattern equals get tower type. We also have like some other variables that I'm going to use later that I just have to initialize here. Also, the reason why this is not working. Oh, it's because this is the wrong thing. It should be painting tower type. Then we also want to say, just initializing some things I'm going to use later. This is going to like count how many turns it's been since you last painted something. This is just going to count how many turns you've been painting for. We also want to set this variable, just like keep track of which ruin that we're worried about. All right. Yeah, that should be about all that we need for this. So once we determine that we're close enough to the ruin, we transition to this state. And that's about all we need to add to our exploring state right now. Now that we've transitioned to this state, I'm going to go into that algorithm for painting. So if we're in the painting pattern state here, we call this run paint pattern function that I've already defined. And that brings us down here. And here is sort of the high level of how this is going to work. It's not going to be like too huge brain or anything. Like it's just the main goal is to be able to paint a pattern with one robot without running out of paint and without like stopping the pattern halfway through. So the first thing we're going to do is we're going to try to move in a circle around the ruin that we're painting and sort of paint as we go. And we really only have to paint like once every 3 turns because like probably we'll have to fill in squares about 3 times before we need to move forward and start filling in some new like farther away squares. So I'm going to say if painting turns mod 3 is 0, then we're going to do our moving logic. So we're going to first get the direction to the ruin. So just say direction to ruin equals rc dot get location dot direction to the ruin location, which is painting ruin location. And then we're going to get like essentially the tangent to, if you can imagine like it's a circle, that's the line like pointing towards the center of the ruin. And we're going to get the tangent to the circle, which is the direction that you would have to move in order to sort of move in a circle around the ruin while painting it. So we're going to say direction tangent equals the ruin direction. And then we're just going to rotate it to the right twice. Since each of these rotations is a 1/8 rotation, and we want to just rotate 90 degrees. And then also we're just going to get the distance to the ruin since that will be useful later. Distance is just rc.getLocation dot distance squared 2, and then the ruin location. Okay, so the first thing is, if we're like pretty far away from the ruin, like more than 2 units, because again, this will be squared distance here. for more than 2 units away, that circle is kind of big. Like we probably want to be closer to the ruin while we're painting. So we're going to rotate to just be like a little bit closer into the ruin. And in order to do that, we're just going to rotate the tangent back left by 1. So it's sort of like pointing into the circle a little bit, which should make it get closer to the ruin as it's painting. And then once we've done that, we really just try to move in that direction. I'm just going to say rc.canMove tangent, rc.move tangent. Ideally, you'd have some other logic here of like, if you can't move in that direction, move in some other smart direction. There's like a bunch more if statements, but I just don't feel like typing them right now. So this should honestly work as long as there's nothing in the way. The next step is like actually painting the tiles. So this is going to happen once every 3 turns, but every single turn, you're going to try to like paint one of the tiles. So we're just going to say, first of all, we only need to do this if we're actually like able to do an action this turn. We're going to sense all of the nearby tiles. I'm sure you guys have done lots of stuff like this before for your current like pattern painting algorithms. So we just get the map infos that are like pretty close to the robot. I'm also just going to make this flag to check if we were actually able to paint any tiles successfully, since that will be useful later. We're then just going to loop through all the map infos. And then we want to get the location that we're going to paint. So we just say, get the location of that map info. And then here's the sort of interesting part that's like maybe different than other algorithms is we're trying to avoid using the mark pattern function, partially because of the bytecode cost and partially because it costs paint. And it's honestly very easy to just implement this functionality yourself and like not use the pattern marking, which like pretty much all the top teams did, and will end up saving you some resources. So how you can do this like without the mark pattern functionality, go back up to these helper functions. We're going to use this function to determine what primary or secondary you should be drawing. Just 1 second. Yeah. Okay, so this laptop is funky.
I can navigate if you want.
Okay,
Where are you trying to go?
scroll down slightly.
Yeah.
Okay, so the first thing is I've already implemented this function that's going to check if the location that we're asking about is actually like even part of a pattern or not. Because if it's not, then we shouldn't be trying to check it. So we're just going to say if this is within pattern, if it's not within the pattern, then we're just going to return false. Otherwise, so I've already pre-saved these patterns here using the get tower pattern functions. This just runs like as soon as you create your robot, and it saved those patterns. And so we now have a Boolean array that tells us what the pattern looks like. So we're just going to use that to figure out what the primary or secondary should be. So we're going to figure out like which column we're in within the pattern, which is just going to be the difference between the location we're trying to paint and the center of the ruin. And then you want to do +2 here, because like if we were up and to the left by 2, it would give us -2, but we actually want that to be column 0. So we're going to say that. We're going to do the same thing for y. And then we're going to just check the pattern array to figure out what the pattern should be at that spot. So we're going to say return. We're going to use another ternary here just to figure out like which pattern we should check. If the type of tower that we're trying to make, if tower type is equal to a paint tower, we want to look at the painting pattern. So it's going to be paint tower pattern of row column. Otherwise, we want it to be money tower pattern of row and column. And that just, gets the primary secondary color that we want. That's it for that function. So we're going to come down here. We're going to say is secondary. Oops. Is secondary. We're going to call that function. So it'll be get is secondary with the ruin location and the location we're trying to paint and the type of tower that we're trying to make. What's that called again? Type. painting tower type. Variable names are too long. Okay, and then we're just gonna check if we can actually paint. So we're gonna say if we can attack location, and like a whole bunch of other conditions that you've probably checked before. And either it's empty or it's already ally paint, but it's like the wrong type of ally paint. So we'll say or info dot get paint dot is secondary. So it is ally paint, but it's like not the right color. So is secondary is not equal to is secondary. And also we want to make sure that it's within the pattern before we try to paint it. So we're going to say also is within pattern. The ruin location and the location we're trying to paint. Okay. If so, then we're just going to attack and paint the tile. So we're going to say rc dot attack the location, and if it should be secondary, fix the indentation here. And then we know that we attacked, so we're going to set the attack flag to true. Turns without attack. You'll see why these are useful later, but we just like need to keep track of all these variables. And then we can stop looking for other locations to paint because you can only paint like one location per turn. Okay. So now that we've done the painting, we need to check like if the pattern is done or if we can build the tower, in which case we can break out of this state in the state machine and go back to exploring or doing something else. So first of all, we're going to check if we can maybe complete the tower pattern. Like maybe pattern's already done. We already have enough resources. Complete tower pattern. Yes, the autocomplete got it right. Almost. Painting ruin location. So if we can complete the pattern, then we're just going to complete the pattern. Complete tower pattern. And then we can go back to the exploring state. So we're going to say robot state dot exploring. The other condition where we might want to break out is like, maybe we did finish the pattern, but we don't actually have enough money to build a tower at the moment. And in that case, we want to avoid just like circling around forever trying to finish the pattern when it's already done. So how we're going to check that the pattern is already done is we're just going to say, if it's been more than 3 turns since you painted a part of the pattern and you were not able to paint anything that entire time, like probably that's because the pattern is done. Because like you had a chance to move at that point, you couldn't find any squares that were paintable. So at that point, just give up and go back to the exploring state. So we're going to do that. Yes, okay, there's one small thing I forgot here. We need to use the attack flag. If we did not attack, then we just need to update turns without attack. And that should be pretty much it for this function. Yeah, let's just go through here quickly and make sure that we don't have any to-dos that are not already filled out. To do. Yep, we already did this. We also already did this. All right, so that's pretty much all the new functionality that we're going to implement. So given all that, we're going to now go try out the bot and see if we can, in particular, see like the new attack micro is like pretty visual, or you can see the robot like getting closer, attacking, moving farther away, and also the new painting algorithm. So we're going to hop over to the clients. Get lecture player here. We'll just use this map and let's run it. See if we get any errors. All right. So I think this is looking pretty good. Obviously, the bot still has a lot of things that should be improved to make it an optimal bot. Like ideally, the game should probably end within that amount of time. But we're sort of just showing different strategies here. So one thing that I want to look at is, let's see this bot in the lower right here. See how it sees the tower, it goes in a circle around the tower, and it's very quickly able to paint the entire thing with just one robot and complete the pattern like in basically the least number of turns possible. Like it couldn't really have been done faster than that. So that's one thing that we implemented. Another thing is, let's see if we can see the new attack micro that we have here. Oh, I think I just saw it. In the top left here, let's slow it down a little bit. You can see how this gold robot here, it goes in, it moves, it attacks, it moves farther away. And this makes it so that the tower can only attack it like every other turn. Well, it's able to attack the tower every single turn, which gives it a significant advantage compared to if you didn't have that micro. So yeah, that's pretty much everything that we had planned for this lecture and lecture player for now. So I hope you guys enjoyed. Does anyone have any questions, comments, anything? All right, I think that's pretty much it. Have anything else?
I think that's it.
All right, well, thank you guys for watching. We'll see you in the next lecture on Friday. Right? Yeah.
Here's
All right.
office hours.
Yeah, office hours tomorrow, another lecture.